Hey everybody, we'll give it a few minutes for folks to join and get started.
And Paul, I was looking at the meeting notes. Is there a set of agenda topics for today?
Yes, there is Jeremy's going to give an update on like the prototyping he's been doing on the multi-cluster services cap.
Awesome. Okay, thank you.
Hey Jeremy.
Hey, how's it going?
It's going okay. How about you?
Good. 2 months in now.
Yeah. Well, why don't we give it till 3 after, and then we can go ahead and get started. I think you've got the floor.
Awesome. Sounds good.
Okay. Okay, Jeremy, I think it's safe to get started.
Okay, cool. So yeah, I wanted to cover a few things today. Let me, I put a little deck together. But I think the first thing is just basically bookkeeping. Let me share. Oh, Paul, you need to enable screen sharing.
Yes. Okay, I'll look at changing that by default, but it's on now.
Okay, cool. All right. Cool. So I guess first things first, I put together a demo based on kind of where the KEP's at right now. First, I threw together, and I'll add this to the notes too, a repo with the CRDs and the Go client generated, so that people can start playing around with what this would look like. And it's bare bones, very simple, but like enough to hopefully get going. And I'm really hoping that we can start collaborating and getting more people involved and kind of playing around with multi-cluster services and what this could look like. I'm not sure what makes the most sense there. I'm certainly happy to keep it going in my GitHub, but maybe it makes sense to have a SIGs project for this. I don't know what thoughts are there.
Do we think it's, how many repos do you think we need?
Yeah, I don't know. I don't know that we want to keep adding a ton of repos. I'm just thinking about like the way SIGNet has been doing Gateway. There's just like a service APIs repo, but maybe it's Kubernetes. Maybe we just, yeah, I don't know. Maybe we just use our existing repo. I don't have a problem with that at all. I just think we need to figure out where we want to put it.
Yeah, I'm not against having a SIGs project at all. I think before we start creating them, let's think carefully about like what the next 2 or 3 like development milestones would be, and try to shoot for that rather than like where we might be right at this moment in terms of repo creation. Yeah.
Yeah, absolutely. And yeah, just one more there for anyone who wants to play around. I'll also share this. I think it's already linked, but I've got a demo repo where basically you follow these steps. You'll get a implementation, a very simple bash controller for MCS, for the MCS API, that basically spins up a second kube proxy that only cares about the service imports and connects all your services that way. There's no DNS or anything yet, but it'll actually build kube proxy. It's very hacky, and it just does it out of my own Kubernetes branch, and then it'll install it and run it locally in 2 Kind clusters, so that there's actually something you can play with. But yeah, so no DNS yet. The controller is just a script. It's very simple, but it shows that everything works with CRDs, which I think is where we got to what we wanted to start with last time. The other kind of big open question, and I don't know if I want to talk about this first or later. Basically, the other 2 things I wanted to cover today are starting to talk about headless services, and then next steps and kind of what we need to do, what we actually want the next milestone to be, and what it would take for us to consider this a worthwhile API. What do you think we should cover first?
Is the demo different than what you showed last time?
No, it functions exactly the same way. Only last time it was Protos, like a first-party API. This time it's CRDs, but there's actually no change at all in the flow.
Okay. Were you able to get it to work correctly with CRDs?
Yes.
That's great. Okay.
Yeah, and anyone can pull this down, try it out. Hopefully, if my setup scripts work properly. Yeah, it absolutely works with CRDs. It is a second kube proxy, so that there's definitely some scaling concerns because you've got basically 2 controllers programming IP tables in conflict with each other, which each are taking locks, and there's issues around that. So I don't think this is exactly how we'd want it to go long term. But yeah, the second kube proxy just watches the service import CRD, and it watches endpoint slices that are marked with the service proxy name annotation so that they're ignored by the core kube proxy. So it all works with CRDs, which is great.
Mm-hmm. I'm game to talk about different types of services.
Okay, cool. So there's been some conversations back and forth on the PR, and I've got some more ideas for follow-up PR. I think last time we talked about not really wanting to overload the first one anymore, but I think we're all set now to actually get the first one merged.
Yeah, maybe we can just pause on that. So I had a PR to update an outdated list of approvers for the SIG that got merged. So I think I should be able to go and merge your KEP in provisional later on today, but the proof's in the pudding. We'll see.
Yeah, I think so too. Also, I saw that there was we actually have like an owner's file set up in our in the SIG Multicluster KEP directory now too. So, and it does include you, Paul. So I think hopefully we're good. But yeah, so once that's done, then I've got a follow-up PR that kind of addresses a lot of things that I want to talk about today. So I'll update it based on our discussions. But I guess let's talk about headless services because we haven't really got there. And initially we said that we'd kind of hold off on stateful sets until we started having more discussion. And basically we just target stateless at first, but I think it's probably time to talk about headless. It keeps coming up. And so I guess the first thing is the idea that we should probably derive this from source services, because this isn't something that's likely to vary in behavior. I don't think you'll want like a cluster IP in a cluster, but you'd want it headless supercluster or vice versa. So the idea basically being that this is an all or nothing state that's derived from source services. So if all of the services that export a given, or all of the clusters that export a given supercluster service are headless, or have the service as a headless service, then we just consider the supercluster service headless. Does that kind of make sense to everyone?
So do you anticipate something in like the API that reflects that?
Yeah.
Either
so I think,
in spec, or I heard something like a status behavior from what you just described.
yeah. Well, so this brings up a question that kind of came up and a few times is service import. Like it really can exist separately. Like it doesn't technically need to be derived from source services. It just that's how we're using it, right? Like a service import really just is a multi-cluster service. So, you know, in the case that we're talking about, the multi-cluster service controller owns that resource, and so it creates it with a current spec based on whatever it derives from source clusters. But there's nothing stopping me from just creating my own service import manually that references a bunch of other clusters. So it kind of brings up the question, like, it seems like either everything on a service import is actually status, and we just consider it all derived, or it's okay that it's all spec. But I don't see a huge difference between like the IP, for example, and whether or not a service is headless in terms of like who's responsible for that. Does that make sense?
Yeah, it does make sense. It might. So what I heard you describe is sounds to me like a status behavior. It's worth thinking hard about.
Yeah. So let's take a step back for a second. So I do think there needs to be a type, and I guess the question is it, so like standard type would be supercluster IP, headless type would be headless. I think we should make that more explicit and not extend the cluster IP none behavior. I think that's, you know, in hindsight, that's probably a little confusing. So make it explicit, but then, yeah, should it be a status, and then should everything be a status? Or, since like the real value in a status is that I can create a resource and a controller can populate the status, right? So if the controller is both creating the resource and populating the status, does that distinction really help?
I think it's important, like regardless of the implementation details, to present an API like users will expect.
Mm-hmm.
So whether the controller is creating the resource and then updating its status, like that doesn't mean that it should just be spec, I don't think. So what happens if I have in like my supercluster is clusters ABC, and in C, for whatever reason, the service is cluster IP, and in A and B it's headless?
So with this proposal that I threw out here, then we just treat it as a supercluster IP service. Now, I don't know that that's the right way to go about it, but basically it's only headless if all of the source services are headless.
Yeah. So I guess I could see the value of a spec field for type would be to enforce constraints like that. Like enforce a constraint that if you say a service is headless, that it's headless in each of the clusters. I think it's really hard to know exactly what people are going to want to do. It's something to think about.
Yeah.
Maybe an initial way to start would be like have a status field that says it's headless in every cluster.
Yep. Yeah. So maybe the like there's a concept of like a clusters list basically on the service import that has cluster specific information, and maybe that should have the cluster specific headless state. Maybe that's status. That's really more of a status thing than that, like that whole clusters list is really status. And then you can use that to kind of figure out the service import. I guess the question is like, so thought experiments, I can definitely come up with ways that this is confusing and this behavior isn't good, but like in practice, I'm having trouble thinking of a case where where you would actually mix and match headless and non-headless services. Like it seems like it's either headless or it's not everywhere. Like it wouldn't make sense to create a service with a cluster IP and a headless service for the same workloads. And that's kind of what we're saying, is that these across the supercluster, or go ahead.
So I think having it be explicit in terms of defining the type is actually going to be easier, simply because I think it's more usable, right? You're not having to kind of guess or derive. I think as you have content or configuration spread across many clusters, the system which updates that configuration or the users that modify it might make errors, right? Simply because there are more places where someone might introduce a change and cause a change in behavior, a derived change in behavior not expected. I also kind of think that where you're talking about should the controller update spec or update status, I think that if you're generating information like the cluster list, or whether it's a successfully cluster IP or successfully headless based on some set of conditions in the background, if you're modifying the spec, then I think it makes it more confusing when you want to manage that object under a GitOps style flow, where I've got many clusters, I'm delivering content to those clusters, I apply a certain spec, and then suddenly the controller modifies it. Was that a valid change or an invalid change, versus the controller modified a status, which provided me all the details that I could still get to through an API call or through the CLI, but not necessarily confusing or invalidating my GitOps flow to deliver that configuration.
Yeah, so that makes sense. I think that brings up a kind of fundamental question that I think we touched on like a few weeks ago and kind of put it to rest, but I'm not sure we really consciously put it to rest, so I want to bring it back up. But basically, the KEP today sees a service import as like a purely derived resource. So it's not something that a user will directly interact with. So it would be created by a controller in response to service exports being in other clusters, or it could be created by a GitOps workflow directly. But there's no real separation. Like, so would we instead want this to be something that a user could create and a controller update separately? And that's kind of the status. Like a GitOps workflow could create a service import in specific clusters. And the controller could fill in the status based on service exports.
So it's not considered to be the type as a property of the service import in the spec, no? I mean, you're completely considering that should be part of the status.
The type?
I mean, the type, if it is headless or is not headless, depending on the cluster, you might have different types. That's what I understood.
Well, so I guess that's something that we need to kind of decide on. Like, it seems like it would be reasonable if I was creating a service import and expecting a controller to fill it in, I could set a type. So that would be kind of the spec. But if it's purely derived, then it feels more like a status.
So I feel like you've probably got a consumption mode in mind when you create a service import, that you either expect load balancing or you don't.
Right.
That points me in the direction of a spec field. I think orthogonal from that, so for example, if I create an import and expect like cluster IP type behavior from it and load balancing, I, as someone who's not a networking expert at all, would expect that there might be problems fulfilling that if one of the exported services was headless.
Yes. Yeah, I think that's that makes sense.
So maybe there's also a status component to that it attests to the exported services being compatible with your import.
Yep, I think that makes sense too. So this, I guess the thing I want to kind of put to rest here is, so the KEP today kind of basically assumes that users don't actually create service imports. It is the controller solely managing it. And so like they would always have the managed by annotation pointing at your supercluster service implementation. In which case,
either way, it seems like the knowledge and intent has to come from somewhere, right?
Yeah. So I agree that like it seems like either way we should have like we should list for the source clusters whether they're headless or not, so you can see how it relates to the derived status, or the, you know, or if you were to specify the status, how it, or a headless sorry, a type, you could verify that it's actually workable. Yeah, actually, let's look at, so I haven't updated the names to service import based on feedback, but let's actually look at the types here. So I guess what here would make sense to be spec and what here would make sense to be status.
I think all of this information looks to me like spec.
Yeah, to me,
Like,
too. Yeah.
Yeah. And so I think, yeah, I agree. And so I think type probably is also spec, because that's how it is, that's how we're actually going to process the service, right? So if it's headless or not. Maybe though, it also makes sense to have status, which is just per cluster status, that can basically say the source service type. Would that make sense?
yeah, I think that's one possibility. Another possibility would be like the exposed. So sorry. Another possibility would be, does instead of like presenting the type directly, a condition that would be like the type of the exported service in every cluster is compatible with this one. So it shouldn't be a problem if you want to consume well, it may not be a problem if you want to consume a cluster IP service as headless and just directly address the pods in that service, but vice versa probably may have problems.
Right.
So it's a question of ultimately like what's the most meaningful thing to the user. Certainly exposing the type in every cluster is a fine way to start.
Okay. I'll draft that up.
Okay.
And then, so there would be a type, which is the type of the service import, and then there would be per cluster status. So you can relate the two. Cool. So then I guess practically though, what do we do with that, right? So presumably with a headless service, if you just talk to the service address, you'd get A records for all backing pods. But then it starts getting tricky. What do we actually do with the per pod name? So, you know, I think the obvious solution, whether or not it's good, is just add a cluster name. And we already have this concept in the KEP of a cluster name or cluster identifier, which is basically a registry scoped unique ID for a cluster. If we add the constraint that that the cluster name has to be a valid DNS label, then we could simply make the per pod address be pod.cluster.service namespace, which seems workable. You know, the main concern here is if you have stateful sets deployed in each cluster, and you just are using the same stateful set spec, then you're going to get conflicting host names in all of your clusters, right? So we need to add something else in there, and this basically means that your endpoint host name in your in the supercluster needs to add the source cluster, the value from the source cluster annotation when we're creating addresses. Yeah, go ahead.
Yeah, I think the formulation of the endpoint and pod names make a lot of sense to me. The only effect, as you have noticed, that I can, or that you noted, that I can personally think of, is that whatever identifier you use for the cluster has to be a valid DNS subdomain.
Right.
Not a controversial restriction in general for cube types. Like, there's many types that already have that constraint,
right.
But just something to note.
Yeah, so we'd want to spell that out and what restrictions that actually comes with, but it seems probably workable. I mean, you know, there are lots of ways to solve that. It still has a lot of flexibility, and it makes this much easier, and actually lets us support stateful sets where ideally I could have, you know, my Cassandra deployment in each cluster and not have to worry about conflicts. Is there anything else that we need to be thinking about here if we wanted to support stateful sets? Does this actually seem like it would work?
I don't personally know enough to say off the top of my head. I would be very curious to have someone who is an expert in stateful sets weigh in.
Yeah, that is not me. From all my digging, this seems like it would work, but this is probably worth a follow-up.
Yeah, it's worth maybe a follow-up with one of the owners of stateful set.
Yep. Yeah, that makes sense. Cool. I will, once that next PR is up, so I wrote up all of this in the follow-up PR, and once that's up for review, I'll try to get some more people chiming in there. High level, this seems like it could work. One other question I had too was, so this addresses the top level service and the per pod addressing. Would there actually be any value in being able to say, like, give me all the endpoints in cluster A? So this would mean addressing just the cluster.service.namespace.
So in the storied history of Kubernetes multicluster, there was in KubeFed and Federation v1 a concept of exposing different layers of endpoints for things, so that you could, if you wanted, address a service bounded to what was deployed in a particular availability zone or particular cluster. So it's definitely a use case that's gotten some attention. How much people want it, I don't know if I can say.
Yeah,
I would say at a minimum, we shouldn't make it impossible to do.
Right. I guess so. One of the things that we probably need to do before this becomes more real, and I don't know if that's before it's implementable or if this is before it goes beta or, you know, where, but we're going to need a detailed multi-cluster service DNS spec. And I guess the question is this something that you could implement if you wanted to, or is this something that makes it into the spec? And I don't know that that really needs to be answered today. But yeah, that would be a question there.
Agree, that seems to be a question to answer. I would, in terms of like a multi-cluster DNS spec, I think it's probably profitable to create one long before beta. Like it should be a living thing that exists even in alpha.
Yep, completely agree. And fortunately, I think we have a good place to start. Like everything we've talked about through this entire process has been very much in line with how things work in a single cluster. So, you know, I think we can start by copy and pasting today's cluster local spec and making a few changes and go from there.
Yeah.
Because hopefully it ends up functioning in a very familiar way. Like it shouldn't be hard to consume multi-cluster services. That's the point.
Yeah. Yeah, I agree. At least shouldn't be a whole different world than consuming on cluster services.
Right, exactly. So, and some of the questions that came up too on the PR, maybe worth spending a few minutes on, are like, so today we talk about the supercluster IP as kind of the standard and it behaving just like a cluster IP. So we make the guarantee that there is a VIP in each cluster that resolves to this or that routes to the supercluster service. So that has a one-to-one mapping. And one of the questions came up is, should that be spec or should that be an implementation detail? Like if someone wanted to have multiple VIPs behind the base supercluster service name, would that be okay? Now, my take is that starts getting risky because there are advantages to having a single VIP that you lose as soon as you start having, you break that guarantee. But since that came up on the PR, I just wanted to bring it up here.
I think this is another area where it's much easier to start small and start highly constrained and gradually relax constraints as demand dictates, basically. So in terms of keeping things simpler and more constrained, I would say that having one is the minimum, right?
Yeah.
You need at least one. I in general feel like super conservative about keeping this particular problem like very constrained at first. So that's where I'm leaning.
Yeah, I'm with you there too. Also, you know that with a single VIP behind the supercluster service name, behavior will be the same as a cluster local service. So the story of just change cluster.local to supercluster.local seems a lot more likely to work.
What's the motivation for multiple VIPs?
Well, like Submariner, for example, can expose a cluster IP to multiple clusters. So you could have it so that just the list of existing cluster IPs for that service and the other clusters get returned, which works. But then, like the main value in the VIP is that you don't have to rely on a good DNS client, which are historically pretty rare. So
yeah.
if you then break that, now all of a sudden, depending on the implementation, multi-cluster services may only work if your DNS client is a good one.
Yeah, I think my bias is let's keep it at one. And if a lot of people are coming to us and saying that like they use Submariner or Scupper or some other thing in the space so they don't need that, that's a signal to us. But I think it will be easier to just constrain it for now and have it act more like a cluster IP service.
Cool. Yeah, that makes sense to me. All right, cool. So that's a lot to work with here, and I will draft up this feedback too. I think probably good in the last little bit here to move on to next steps. So so for approvers, Tim volunteered, and I think that makes sense as a for kubeproxy implications. And Paul, I have volunteered you as an approver. for now,
Okay.
if you're all right with that. And then I think it would be helpful to have more reviewers.
Yeah, I think it would definitely be helpful to identify reviewers that could attest to, you know, the compatibility of decisions that we're making with like other key related parts of the system. Like, I'd love to get a stateful set owner.
Yeah.
I'd love to get someone that was well versed in networking as a reviewer too.
Yeah. Cool, and DNS probably as well.
Yeah.
Cool. I can keep following up on that too. You know, without digging too much into the rest of this, I guess what do we think? What do we think is required to make this implementable?
Good question. I really want to zoom in and talk about this test plan thing.
Yeah, I think that's probably. I think probably both of these things. I don't think we can go alpha without having an understanding of what it means to go to beta, and we certainly can't do anything without a test plan.
Yeah. So thinking of how we would test the dev setup with an additional kube proxy and CRD API, I want to understand the enclosing scope of like the EDE testing with kind. So is that like a host where I'm running multiple clusters with kind?
Yeah, that's how I set up the demo, and that seems like a good workable, so you could run it locally.
So it's like a one host is the boundary of the supercluster, and you're running multiple kind clusters in containers on the host, right?
Exactly.
I think that is certainly a sensible place to start. Testing things that depend on multiple clusters is not easy. That like having a host and running a cluster in a container is a good way to start.
Yeah, that's my take too. This doesn't address, you know, scalability concerns or anything like that. Obviously, as soon as you actually leave the host, things get a lot more complicated. I'm not sure
it also
that
doesn't address like viability on any cloud provider or any supported Kube as a service offering, right?
Exactly. And it might be that like some cloud providers, it just works. Some cloud providers work if you install something like Submariner. You know, basically everything we've talked about has a flat network requirement between your clusters. So either you need to run somewhere where it is a flat network, or you need to be able to flatten the network. Fortunately, it's very easy to flatten kind networks. So that seems like a good place to start. But yeah, I think this needs to evolve a lot. I'm less certain that needs to happen like prior to alpha. I think it's
so. Here's a little
beta
puzzler.
requirement. Yeah.
Thinking about the kind-based EDE setup, how would we get that out of Prow? Because I think that's what's on offer from the community is a Prow instance.
Yeah.
An alternative might be use the free Travis plan, and then you can get a VM, and you can get something that you can run containers on, but then you take on the constraints of Travis, that you have a pretty hard timeline or timeout deadline that you're up against. As like the big thing that I've run into testing substantial projects with Travis before. It might be a good first step.
I might be off on this, but I had recently put in a PR on a different project, and the Prow ran an end-to-end test using kind, it seemed. At least the test case described it that way. So
I would
I'm
be
not sure
super
whether
interested to see a link to that.
Yeah. Yeah, that'd be
I'll
great.
look through the end-to-end and see if I can find it, but the test description was relating to it running IPv6 testing on kind.
Okay, I mean, that would be awesome. And it kind of makes sense because I know that, you know, testing Kubernetes is like the primary motivation behind kind, but I didn't know if that was like an end integration test or if that was actually testing during development.
On Submariner, we've been using kind for end-to-end tests on Travis and GitHub Actions, and it works quite well with both.
Okay, awesome. So this seems like there's some open questions here, but it seems like it's definitely solvable.
Yeah. Another thing that we've run into that isn't an immediate concern, but it's just it's something to note, is that we have never managed, I don't think, to get budget to test KubeFed or Federation with a cloud provider provided setup. So there's a future question of if we want to test in the Kube community with different cubes as a service, that might be a hurdle we've got to jump.
Yeah, no, that's a good point. So that's even more reason to figure out how to make it work with kind for now. But yeah, I agree with. I wonder too, since the main idea here is that, you know, we want to be open to different implementations. Maybe it's like we have the canonical implementation with kind, and then other implementations kind of have to provide their own EDE testing.
Yeah.
Maybe that's an acceptable answer, but yeah, we should follow up on that and understand.
I guess there's a possibility of if a particular vendor is really interested in establishing that X or Y thing works correctly on their platform, they can donate a CI job.
Yeah,
right? Like I think there's something similar for node EDEs in Cube. At least at one point, they ran on a random provider that you couldn't select explicitly to get like a balance of different providers that the node EDE ran on.
that makes sense. Yeah, okay, that seems like a good solution too. And yeah, maybe there's a few of those if a few cloud providers think that this is something they definitely want to prove they support. That's great. That seems less likely to happen before alpha, but definitely worth pursuing. Cool. I guess what else do we think needs to be hammered out before this is considered implementable? I would say right now the big thing testing is having an actual plan to get this running either in Prow or in Travis or something automated.
Yeah, definitely. We need to understand if we're eventually dependent on a kube proxy KEP or not.
Yes.
As at least one multi-100-pound gorilla in the room.
Yeah.
When do you think there's enough to show that we can like engage SIG network folks in like test receptivity to like a kube proxy plugin KEP?
I mean, I think kind of now. So I actually showed, like, there are some SIG network folks commenting on the PR, and I pointed them at it. I went to a SIG network meetup a while ago and pointed them at it. Initial reception from the folks that I've talked to has been very against the idea of a separate kube proxy. So definitely for kube proxy support. I think it's worth revisiting that, but we probably have enough now to talk about what that's like.
Yeah. Any explicit signal on like kube proxy extensions?
Some, I guess the haven't dug into that too much because that seems like a whole can of worms. Like I think general consensus is it would be great if kubeproxy was easy to extend. Actually making it so that we can create like out of tree plugins for kubeproxy. There are ways we could do that for sure, but like building that API might be on the same level as this API, you know?
Yeah. Yeah, so I think a lot hinges on like in tree or out of tree extension to the proxy.
Yeah.
Because if it's in tree, I think the target API effectively is part of Kubernetes /API.
Yeah.
If it's out of tree, it can be a CRD, but then there's the challenges of out of tree extension.
Right, and so yeah, that's my take too. Like CRD only makes sense if it's an out of tree plugin. It doesn't make sense that kubeproxy would understand, you know, an out of tree CRD.
Right.
So if kubeproxy understands service import, then this should be a first class API.
Yeah.
So
okay,
I
think
can
we're
revisit that with SIGNet for sure.
Yeah, it's something to figure out. I think we're at time for today. So thanks a lot for the update.
Yeah, absolutely.
And offline, I will work with you to get the KEP merged as provisional.
Okay, sounds good. And I'll try to follow up on these, you know, for next week, and hopefully we can have an update. Maybe it's not as long then.
All right, great. Thanks a lot, Jeremy. Thanks, everybody. Have a good day. All right, bye.
Thank you.